Very good evening friends, this is Professor Vishal and we are going to continue our solution of first exercise from the first chapter of the chemistry, that is some basic concepts of chemistry. Okay, so in up to this we solved three questions and sub questions included in that particular questions. Now we are going to discuss about the fourth question, that is solve problems. Question is like this: solve problem. So in this question total 11 to 12 questions are there and we are going to solve each and every question with proper understanding. Okay, so let us start with question number A. So this is first question from this is first of question from this main question number 4. So question is like this: what is the ratio of molecules in 1 mole of NH3 and 1 mole of HNO3? Means we have to find out the ratio of molecules. So before starting this we must know the concept. 1 mole of any substance contains, that is 1 mole of any substance of or we can say 1 mole contains how many particles? That is 6.022 into 10 raised to 23 particles. Particles may be entities, it may be molecules, atoms, ions, whatever it may be. 1 mole means 6.022 into 10 raised to 23. We have seen this in mole concept, okay, in theory portion. So now if I want to calculate 1 mole of NH3, so how much it should be? Again it should be same, it is 6.022 into 10 raised to 23, isn't it? Or and similarly for 1 mole of HNO3, it is also equal to 6.022 into 10 raised to 23, because 1 mole of any substance is what? This much amount of particles. Any substance, whether it is NH3, whether it is NHO3, HNO3, or whether it is H2O, or whether it is any compound, for 1 mole, when we define 1 mole, this means this much amount of particles. Now we have to find out the ratio of their molecules. Means what? Ratio is nothing but 1 mole of NH3 to the 1 mole of HNO3, isn't it? And it is also 6.02 into 10 raised to 23, and this is also 6.022 into 10 raised to 23. Okay, when I will divide this, I will get this ratio as a 1:1, and this is what your answer is. The ratio of the molecules of NH3 and HNO3 is found to be 1:1. Okay, so for which we must know this concept of mole. 1 mole of any substance is 6.02 into 10 raised to 23 particles, whether it is NH3, whether it is NH3 or HNO3, or instead of these two, if any compound is given. When we discuss about 1 mole, this must be same quantity, and when we take the ratio of same quantity, we will get 1:1. Okay, so this is how we are going to solve this first question from the first sub question from the fourth question. Okay, now we are going to discuss about second sub question, that is question number B. Now the second sub question is like this: calculate number of moles of hydrogen in 0.448 liter of hydrogen gas at STP condition. Means for 0.448 liter of hydrogen gas contains how many number of moles? Okay, so as we all know the formula for number of moles. So here I have I'm going to write this volume of hydrogen at STP. It is given. So this is 0.448 liter means what? This is nothing but the volume of hydrogen gas. So I can write here volume of hydrogen gas at STP, which is given as 0.448 liter, isn't it? Now we all know the formula: number of moles equal to volume of gas at STP to the molar volume of gas to the molar, so this should be molar volume, isn't it? Now if we know these two terms, we can easily get the number of moles, and that is what we have to calculate. Okay, so here if you see, volume of gas, volume of gas at STP is already given. It is 4.448 liter, and molar volume of gas, as we all know, this is constant value. It is 22.4 decimeter cube. Okay, when we convert it into liter, it becomes 22.4 liter. So just write this. So I can write here molar volume of gas, which is equal to 22.4 decimeter cube per mole, isn't it? So this can be written as 22.4 liter at STP. So when we put the value in the formula, number of moles equal to volume of gas at STP divided by molar volume. So volume of gas, number of moles denoted by small n, and volume of gas at STP, which is given in your problem, is 0.448 in terms of liter, isn't it? So here unit is liter, and this molar volume of a gas, here molar volume of gas in terms of liter is 22.4 liter per mole. Okay, so if you solve it, you will come to know it is found to be 0.02, and unit should be mole, because this mole inverse is converted to mole. This liter gets cancelled out, and this is what your answer is. Means according to question, if you read the question, it is like this: calculate the number of moles of hydrogen are present in this much amount of volume, that is 0.4 liter of volume. Then we can say that 0.448 liter of hydrogen gas means what? It contains 0.02 moles. So this is the way you are going to calculate the number of moles when the number when the any particular gas given in terms of liter. Okay, so we can easily find out the number of moles using this formula: number of moles of gas equal to volume of gas at STP and molar volume. So molar volume is always 22.4 decimeter cube per mole, and molar volume of gas is which is given in this problem already. Okay, so we just convert this decimeter cube per mole into liter, and we'll put the values in the formula. We will get this answer. Okay, so this is how the simple question it is. Only the thing is that we must know the formula, and we have to convert this into proper same unit, and we will get our answer. Okay, so after this we are going to discuss about third sub question, that is question number C. Now the question is like this: the mass of an atom of hydrogen, the mass of an atom of hydrogen is 1.008 U, or we can write it as a AMU. What is the mass of 18 atoms? What is the mass of 18 atoms of hydrogen? Okay, question is like this: mass of one atom of hydrogen is given, and we have to find out mass of 18 atoms. So I can write here, very easy question actually. Mass of one atom of hydrogen is 1.008 U. Okay, and therefore I in order to calculate mass of 18 atoms of hydrogen can be calculated as 18 into 1.008. Okay, if we solve it, it becomes 18.144 unit. Very simple. Means you have to use here unitary method. For one atom it is 1.008, so for 18 atoms it should be 18 into 1.008. Here instead of 18, whatever the number is given in your question, you have to multiply it by mass of one atom of hydrogen. You will get your answer in very effective and accurate way. Okay, so such type of questions will also be there, so that are very easy to solve actually, but we must know the basic idea behind this question. Okay, so this is how, this is very easy question, or we can say it is Such type of questions we already solve in 8th standard or 9th standard, isn't it? Or even less than that, isn't it? So after this we will proceed for our next question. So question number D. So this question is like this: calculate the number of atoms. We have to calculate number of atoms in each of the following. In each of the following. Actually two elements are given. For first it is given as 254 U of iodine, or we call it as AMU, isn't it? And that is I. And second one is 254 gram of iodine. You have to find out the number of atoms in iodine. First it is 254 unit. This is given as molar mass. This is particularly molecular mass, and this will be your molar mass. Okay, we have to find out the number of atoms in each case. Whereas the atomic mass of iodine is given, so it is atomic mass iodine, it is 127 U. Okay, so this is how we are going to read the question carefully and give the answer. Means what? In short, we have to find out the number of atoms only. For first case it is 254 unit of iodine, or unitary mass of iodine, and second 254 gram of iodine. Okay, so see, firstly we can say that if I can write this 254 unit of iodine means, let us say X atom. Firstly what I will assume, 254 units of iodine, let us say it contains unknown, so I am writing unknown as X. It contains X atoms. Okay, and atomic mass of iodine is given. Here atomic mass is given, therefore I can write atomic mass of iodine it is 127 U, isn't it? Therefore what we can say, atomic mass means what? It is only the mass of one iodine atom, isn't it? Atomic mass represents one. Yes, atomic mass means what? It is nothing but the mass of one atom, iodine atom. Therefore atomic mass means what? Mass of one iodine atom, which is 127 U. Means what? Let us say if mass of one iodine atom is 127 U, then mass of X atoms will be, therefore I can write this X atoms. For X atoms it should be 254 U upon 127 U. Simple, I am using unitary method over here. By unitary method you can mention reason also, no issue. Okay, simply what it means, here atomic mass of iodine is already given, it is 127 unit. Atomic mass means what? Atomic mass is nothing but, for any element atomic mass is nothing but mass of one atom of that element. Here atomic mass of iodine is given as 127 unit, means mass of one iodine atom is 127 unit. Okay, and for one atom it is 127 unit. For X atoms 127 into X upon 254, so therefore X equal to 254 upon 127, isn't it? And when we solve it, it is very easy. So we will get, so here therefore X equal to 254 unit upon 127, so it will get very easy calculation. We will get two atoms. Means what? In short, 254 U of iodine contains two atoms only. Okay, so this is how we will solve. This is your solution of first sub question. Now moving ahead, the solution of second question. Okay, so here what they will ask, they will ask the number of atoms in 254 gram of iodine. Okay, so atomic mass of iodine, it is 127 unitary mass, it is already given. So this is what atomic mass. If atomic mass is 127 U, and molar mass means what? Molar mass is the only change in unit, that is 127 gram per mole. Okay, so we are using the same formula, number of moles equal to mass of a substance upon molar mass of the same substance. Okay, so here mass of the substance is already given in terms of gram. It is 254 gram, isn't it? And molar mass means what? Molar mass is nothing but the atomic mass. If atomic mass is in terms of AMU, molar mass must be in terms of gram per mole. That is the only change. Only unit will be changed. So therefore it will be 127 and unit is gram per mole. Okay, so it is very easy. Gram gets cancelled out. 127 2s are 254. So here we can say we will get 2 moles. Now first, in order to calculate the number of atoms, firstly we have to calculate the number of moles. And as we all know, from number of moles, if I want to calculate number of atoms, I have to multiply it by Avogadro constant. Okay, so whether I have to calculate number of molecules, whether I have to calculate number of atoms, once I will get number of moles and I will multiply it by Avogadro's constant, I will get number of atoms or molecules respectively, whatever the entity which is asked in your question. Okay, so here we are interested to calculate the number of atoms. So what we are doing, number of atoms equal to number of moles into Avogadro constant. Okay, means when we multiply this number of moles 2 into Avogadro constant, that gives me number of atoms. Okay, so we will put the value and solve this question. Very easy question. Only the thing is that you must know some basic parameters in it. Okay, so here I will put the value. I will get number of atoms as number of moles are 2 and Avogadro's constant is 6.022 into 10 raised to 23. Okay, so if I will solve it, I will get, so this is what, this is number of moles, so this must be, multiplication must be 12.044 into 10 raised to 23 atoms, or we can also write this as a 1.2044 into 10 raised to 24 atoms. Okay, so this is how your answer is. Okay, so this is also correct and this is also correct. Just I am putting the one decimal point before, so I am adding one more term here. Okay, in the power. So here this way you can easily calculate the number of atoms. So here there may be change in question. So instead of this, like in this question, instead of number of atoms, if they will ask you number of molecules, so you can use the same formula. So here instead of atom you have to write the number of molecules. Only the thing is change, you will get your same answer. Okay, so this formula is most important in this case. Okay, so once you calculate number of moles and then we multiply it by Avogadro constant, we will get number of atom. And one more thing, here most of the students confuse that, sir, molar mass is not given in question. Actually they will never give you molar mass, they will give you atomic mass. If the atomic mass, let us say in this case, if atomic mass is given is 127 unit, only you have to change the unit. In case of molar mass, molar mass is itself atomic mass. Only in case of atomic mass, it is atomic mass unit is atomic mass unit. In case of molar mass, quantity will remain same and unit is gram per mole. That gives me molar mass, and when I will put the value, it can be easier for me to solve such type of questions. Okay, so after this we will proceed. So we solve these two problems. First, the answer is 2 atoms in case of 254 U of iodine, and in case of 254 gram of iodine, I will say I will get this much amount of atoms, that is 1.2044 into 10 raised to 24 atoms. Okay, so in this way you can use the simple formulas. See, if you observe, you will come to know we are using the same formulas. Only we have to read the question carefully and apply the particular concept, and thereby you can use the particular formula. You will get your answer in a very effective and accurate way. Okay, after this we will proceed for our next question. Now moving towards our fifth question. That is, question is like this: a student used a carbon pencil to write his homework. The mass of this was found to be 5 milligram. That particular mass of carbon pencil is found to be 5 milligram. So with the help of this, so this is the data given. So with the help of this, what we have to calculate? We have to calculate first the number of moles of carbon. We have to calculate the number of moles of carbon in his homework writing. In his homework writing. And second question is the number of carbon atoms. The number of carbon atoms in 12 milligram of his homework writing. Of his homework writing. So these two sub questions are given in main question. So we are going to discuss one by one. So here, if you read the question, you will come to know the first data given is 5 milligram of carbon. So the pencil which he is using, so it contains basically the mass of this carbon pencil is found to be 5 milligram. Okay, so what it means, 5 milligram of carbon means what? We have to convert the first into in terms of gram. Okay, generally we are going to get the what we can say, the molar mass in terms of gram, isn't it? It is not in terms of milligram. So we will convert this milligram into gram. So 5 milligram of carbon means what? 5 into 10 raised to minus 3 gram. Okay, of carbon we can say. So we just convert this unit in milligram to gram. Now, as we all know, what is the atomic mass of carbon? So atomic mass of carbon is 12 AMU or 12U. So for atomic mass 12U, what is the value of molar mass? So I already discussed you, molar mass is nothing but atomic mass, but the only change is that magnitude will remain same. See, 12 as it is. Instead of AMU, I am writing this as a gram per mole. Okay, if the atomic mass is expressed in terms of gram per mole, that mass we called it as a molar mass. If atomic mass of carbon is 12U, molar mass of carbon must be 12 gram per mole. Magnitude will remain same. We have to change the unit. Okay, and this gives me molar mass. And as we all know, once you will get molar mass, we have seen in previous problem. So here in this question, we have to find out the number of moles. And as we all know, the formula for number of moles equal to mass of a substance divided by molar mass of that particular substance, or I can write here mass of substance, or in this case mass of a carbon we can say, to the molar mass of same substance, that is of we can say carbon. Now mass of carbon, it is already given in question. It is 5 into 10 raised to minus 3, and molar mass we have seen here, it is 12 gram per mole, isn't it? This unit is also gram. So this will get cancelled out. If we solve it, 5 into 10 raised to minus 3 divided by 12, you will get this answer 4.167 into 10 raised to minus 4 mole. If you have to write here unit also, because we are going to calculate number of moles, and this much amount of moles will be there in 5 milligram of carbon. So this is what the short summary of the question. Okay, means if we take the sample of 5 milligram of carbon, so it contains 4.167 into 10 raised to minus 4 amount of mole. So this is what that is why the units are necessary. Units gives you exact idea about the quantity. Okay, so after this is answer of your first sub question, we can say this is answer of first. Now or you can give number here also. So now we will proceed for calculation of solution of second sub question. Okay, second question is like this: the number of carbon atoms in 12 milligram of his homework writing. Now here only the thing is what we have to calculate the number of carbon atoms. Here in that case we have to calculate number of moles. So let us see. So here also the mass is different. Now if you see 12 milligram of carbon is given, means what, 12 into 10 raised to minus 3 gram of carbon. Okay, we have to convert this milligram into gram first. Okay, then here also we can say you first calculating number of atoms means what, same problem is there. We previously solved this problem, which is the same kind of problem. Again such type of problems gets repeated, so we will discuss once. We have to find out the number of atoms, means firstly we have to find out number of moles, and when we multiply number of moles by the Avogadro constant, that we get gives me number of carbon and number of atoms. So therefore first step I have to calculate the number of moles. Number of moles, exactly the same kind of problem we already solved, but the values are changed, so we will solve it again. It is nothing but the mass of a substance, or in this case it is carbon, divided by molar mass of what, of carbon only. Okay, so mass of substance in this case it is given 12 into 10 raised to minus 3 gram, and molar mass of carbon, that is we already discussed about this in our section, it is 12 gram per mole. This 12 gram get cancelled out, 12 get cancelled out, we will get our answer as a 1 into 10 raised to minus 3 moles. Okay, means what, 12 milligram of carbon contains 1 into 10 raised to minus 3 number of moles only. It is not atoms. Now once we will get moles and we will multiply it by Avogadro constant, that gives me number of atoms. Okay, got it. So now we are going to calculate the number of atoms over here. So now number of atoms equal to number of moles into Avogadro's constant. Now number of moles we calculated as a 1 into 10 raised to minus 3 moles into Avogadro constant is what, 6.022 into 10 raised to 23. So this is what unit is atoms per mole. Okay, so it becomes 6.022 into 10 raised to 20 atoms, because this moles gets cancelled out, the atom is remaining, and that is what our answer is, means number of atoms are found to be 6.02 into 10 raised to 20 in case of in 12 milligram of carbon. So this is how you can easily solve the questions, and you will get answer in a very short way. Only the thing is that if you see before 2 to 3 examples we have used this formula, and already again and again I am repeating, this formula is most important. Whether they will ask you to calculate number of atoms, number of molecules, you have to use the first calculate the number of moles, then we have to use this number of moles and use this formula, that is number of moles equal to, you have to use this formula, number of atoms equal to number of moles into Avogadro's constant. Okay, or if they will ask you number of molecules, I have to use the same formula, number of moles into Avogadro's constant, and that gives you the same value as that of atoms, as that of molecules. Okay, according to question you can use the formula, you will get the same answer. Okay, so we will discuss next question after this.